Okay guys, in this video we're going to look at another example of solving an oblique triangle using the law of sines, and in this particular instance we're going to look at what we refer to as the angle side angle case. And that is to say that when you look at your triangle here, we have two angles and the included side between them. Okay, so as long as we know two angles and the included side, we want to solve this. Let's go ahead before we use our law of sines and just set up our data for ourselves here. And so I notice this is triangle ABC. I'm going to go ahead and label any unknown parts first. And so that would be, let's see here, across from A, capital A, we put lowercase a, across from capital B, we put lowercase b. These are these two unknown sides here. And we have a third unknown angle. Now the neat thing about our unknown angle is, remember that if we know two of our angles already, 15 plus 35, add up to 15 plus 35, 15 plus 35, add up to 50, then if we were to take away 180 or take that away from 180, we would have that difference there being the remainder. So I'm going to go ahead and write 130 degrees here. So again, anytime you know two angles, we already kind of know the third angle here. So we have side length A, side length B, side length C here. And then we're going to put a spot for the measure of angle A, the measure of angle B, and the measure of angle C. And so filling in what we know, it looks like we already know all three angles here. We know the measure of angle C, at least we determined it was 130 degrees here. The measure of angle A looks like 35 degrees, and the measure of angle B is 15 degrees. And of the three sides, we happen to know the measure of angle, or sorry, side length C is 5 units long. So one thing to keep in mind here as we solve this is that remember that opposite our largest angle would be our longest side. Well, I can already tell you that 130 is overwhelmingly the largest angle. So because these other two angles are so small, I know that these two side lengths are going to be less than 5. Now in terms of what we solve for first, the question first of all should be, can we use the law of sines here? So the law of sines can be used, but the reason why is because look at this. We know an angle and we know the side across from it. So we have an angle side pair. So in terms of the law of sines, if we have this angle side pair, let's look for another side length that we don't know and set up the very same ratio, and we'll solve for this unknown measurement. So that is to say that if I'm going to solve, say, for A here, then first of all I would put lowercase a on top of the ratio. Not like it's arranged here, I would put it up top, we would reciprocate everybody, but A over the sine of the angle across from A, which happens to be 35 degrees. Let me rewrite that 3 here. 35 degrees. This would have to be the same thing as lowercase c, which is 5 in length here, 5 units in length, over the sine of 130 degrees. So using our law of sines, we're able to set up this proportion, and this is what's going to allow us to do our cross product and go solve for A. So we get A times the sine of 130 degrees is equal to 5 times the sine of 35 degrees. And just like we have in the past, what we'll do is get A by itself. So we'll divide both sides by the sine of 130 degrees here, sine of 130 degrees. And so what we get is that the A is exactly equal to the 5 times the sine of 35 degrees all over the sine of 130 degrees. And so what we're going to do is we're going to put a box around this. Of course, this is our exact value, but what we're also going to do is find an approximate length. So let's get our calculators rocking. Make sure that you're in degrees mode. But we're going to type on top here 5 times the sine of 35. We need two end parentheses to get everything quantified on top. And we're going to divide this by the sine of 130 degrees. And so by doing this, we get about, out to the nearest tenth. Since this was the nearest whole, we'll go one more place value. Out to the nearest tenth, we get about 3.7 here. 3.7 units of length. And so, of course, once you find this, we always go put it back over here with our data, 3.7-ish. And we always put it on our picture as well because we want to talk about reasonability. So now that we know this, let's now go back and let's solve for this B right here. And so again, we're going to use the initial side angle pair that we have here, but we're going to use it in conjunction with this side angle pair here so we can solve for B. And so because we're looking for lowercase b, we'll put that on top of our fraction, and we'll put that over the sine of the angle across from it. And so we would say, I suppose, the sine of angle B would be the sine of 15 degrees right here. And this would be the same thing as lowercase c, which is this 5 over the sine of 130 degrees right here. And so with this, let's go ahead and do our cross product. We're going to multiply crosswise and set those equal to each other. And so what we would get is this. We get b times the sine of 130 degrees would have to be equal to 5 times the sine of 15 degrees. So now to finish this up, let's go ahead and get b by itself, we're going to divide both sides by the sine of 130 degrees. What you do to one side, we do to the other. And what we end up with is the fact that b is exactly equal to 5 times the sine of 15 degrees, and this is all over the sine of 130 degrees. So here's our exact value. Let's go ahead and get our approximate value here. So in parentheses 5 times the sine of 15 degrees, 2 end parentheses, and we'll divide this by the sine of 130 degrees here. And what we get is about 1.7. So we're going to say this is approximately 1.7. I'm going to write, because this was a side length, the units in length, I'm going to go put my 1.7 over here. And I'm also going to put it on my picture and assess the situation. So in terms of reasonability, is this reasonable? Well, what I notice is this was the shortest side, opposite the smallest angle of rotation. The 3.7 was the intermediate side, opposite the intermediate angle of rotation. And the 5 was the longest side, being opposite the largest angle. So I think this is entirely reasonable. Cheers.